have to go streamer mode. No. Left my headphones at work, boys. Forgot them at my desk. Idiot. Streamer mode. Oh, this looks so dumb. Dude, this looks so dumb. Oh, that's troll. This looks so dumb. This looks so dumb. This looks so dumb. No way. Oh, that looks so stupid. Oh my gosh. I'm gonna have to go streamer mode. It's the only headphones I got. Crap. Ah, streamer mode sucks. Yo, this looks so cringe. I cannot code like this. I've left my headphones at work. No. This looks so dumb. How do people wear this? How do people wear this? This is so dumb. Fly a plane. Yeah, look, am I gonna code? I'm gonna code a plane. Yeah, this looks stupid. Can't wear these. Looks so dumb. Can't wear. Crap. What can we do? Don't have any headphones besides AirPods and my old wired ones. Man, this is gonna be a boring stream. Rip. Alright. Well, I guess we'll start off with some reading then, because we don't have headphones anyways, so might as well. Alright. Oh yeah, I gotta fix the chat. All right. That's the link to the vid. Pop out of the chat. All right. We're good. I think we're good. All right. What page were we on? We were on like 130. Okay, we were on utility functions of normalized text matching. Here we go. All right, we're on page 143 here of Fluent Python. Let's continue on for a little bit, and then I'm gonna work on this Docker project and then call it from there. I forgot my headphones today, so L stream, you guys. Sorry, my bad. Ugh. As we've seen, NFC and NFD, right, which we learned from before, are normalized form C and normalized form D, are safe to use and allow sensible comparisons between Unicode strings. NFC is the best Normalized form for most applications. Stir.casefold is the way to go for case insensitive um, comparisons. If you work with text in many languages, a pair of functions like nfc underscore equal and fold equal in example 413 are useful additions to your toolbox. So example 413, norm eq dot pi, normalized Unicode string comparison. Utility functions for normalized Unicode string comparison using normal form C case sensitive. S1 is equal to cafe. S2 is cafe with a byte sequence representing the accent, right? And then they don't equal to one another. But then if we say if their NFC is equal, that is true. Using normal form C with case folding. Okay, this is equal false, and this is false. Fold. Beyond Unicode normalization and case folding, which are both part of the Unicode standard sometimes, it makes sense to apply deeper transformations, like changing cafe into cafe. We'll see how and when in the next section. Extreme normalization, taking out diacritics. The Google search secret sauce involves many tricks, but one of them apparently is ignoring diacritics, accents, etc. At least in some contexts. Removing diacritics, however you pronounce that, is not a proper form of normalization because it often changes the meaning of words and may produce false positives when searching. But it helps coping with some facts of life. People sometimes are lazy or ignorant about the correct use of diacritics. And spelling rules change over time, meaning that accents come and go in living languages. Outside of searching, getting rid of diacritics um, I can't read that word for some reason. Also makes for more readable URLs, at least in Latin-based languages. Take a look at the URL for the Wikipedia article about the city of Sao Paulo. Right, in Wikipedia which is this, Sao Paulo, okay. The %C3, %A3 part is the URL escaped UTF rendering of the single character of A with a tilde on it. The following is much easier to recognize even if it's not the right spelling. Wikipedia Sao Paulo. To remove all diacritics from speech from a stir, you can use a function like, okay, so let's do diacritics are accents, etc. Okay, so then we have this function here, simplify.py, or a function removing all combining marks. So I'll take this function. Right, so import Unicode data, import string, def shave marks, text. Remove all diacritic marks. Norm text equals Unicode data dot normalize NFD text. Shaved equals do a blank string dot join every character for character in norm text. If not, Unicode data dot combining. Right, so 1 decomposes all characters into base characters and combining marks. Filtered out all combining marks. If it's not, Unicode data combining on C. And then 3 recomposes all characters. Example 4.15 shows a couple of uses of shave marks. 2 examples of shave marks from example 4.14. Order: half cup cafe latte bowl of acai. Shave marks: half cup Greek. Shave marks Greek. Only letters E, C, and I were replaced. Okay. On the shave marks. Then you call shave marks on Greek. And we get rid of the tilde here. And then the epsilon here. The function shave marks from example 4.14 works all right, but maybe it goes too far. Often the reason to remove diacritics is to change Latin text to pure ASCII, but shave marks also changes non-Latin characters like Greek letters, which will never become ASCII just by losing their accent. So it makes sense to analyze each base character and to remove attached marks only if the base character is a letter from the Latin alphabet. What is this example of? This is what example 4.16 does. Example 4.16, a function to remove combining marks from Latin characters. Import statements are omitted as this part of the simplify.py module from example 4.14. So def shave marks given some text. Shave marks Latin. Remove all diacritics marks from Latin-based characters. So we're going to normalize the text into NFD. So we're going to decompose all characters into base and combining marks. The Latin base is equal to false. And preserve is a string, is a list. For every character in the norm text, if it's Unicode combining and it's Latin base, we're going to continue. We don't want to include that one, or we don't want to modify it. And we're going to append to preserve if this if it's not combining character, it's a new base character. Skip over the combining marks from base characters to Latin, otherwise keep current character. Text a new base character and turn it to Latin. Recompose all characters. If it's not Unicode due to combining. But it is Latin base. It's not Latin base, but it is a ASCII that we're going to convert it to a Latin base. An even more radical step would be to replace the common symbols in Western text, curly quotes, em dashes, bullets, etc., in ASCII equivalents. This is what the function ASCIIize does in example 4.17. Transforms from Western typographical symbols into ASCII. This snippet is also part of a simplify.py. So single map equals stir.maketrans. And we have a multi-map equals stir.maketrans this. So in line 1, build mapping table for char-to-char replacement. Build mapping table for char-to-char replacement in line 2. Merge mapping tables in line 3. To summarize, the functions in simplify.py go way beyond standard normalization and perform deep surgery on the text with a good chance of changing its meaning. Only you can decide whether to go so far, knowing the target language of users and how the transformed text will be used. This wraps our discussion finally. Ugh. I just need to get out of this chapter. This chapter sucks. This chapter is terrible. It's so, like, dense. It's kind of niche, too. Sorting Unicode text. Python sorts sequences of any type by comparing the items in each sequence one by one. For strings, this means comparing the code points. Unfortunately, hold on. Python sorts sequences by any type comparing the items in each sequence one by one. For strings, this means comparing the code points. Unfortunately, this produces unacceptable results for anyone who uses non-ASCII characters. Consider sorting a list of fruits grown in Brazil. Fruits equals to these Brazilian fruits. When we sort them, it doesn't sort them appropriately. Sorting rules vary for different locales, but in Portuguese and many languages that use Latin alphabet. What do you think about the book content? Well, so far this chapter sucks. It's like all about Unicode, and I mean it's interesting stuff, but it's like not really super prevalent to stuff I'm doing right now. So it's kind of just toughing through it here. Sorting rules vary for different locales, but in Portuguese, many languages that use Latin alphabet accents and still how do you pronounce that? Rarely make a difference when sorting. So, um, I don't know, I try to pronounce that. Must come before kaja sort of kaja must, and must come before. The sorted fruits list should be this. Kaja and then kaju. The standard way to sort non-ASCII text in Python is to use the local dot stirxfr function, which according to local modules docs transforms a string to one that can be used in local aware comparisons. To enable locale stirx from, you must first set a suitable locale for your application and pray that the OS supports it. The sequence of commands in example 4.14 may work for you. So local sort, using the local.stirxfrm function as the sort key. Import locale. My locale is locale.setlocale, locale.lc.collate, print my locale. And fruits sort of with the ptbr utf-8 locale installed, I get that correct result. So you need to call the set locale lc collate your locale before using locale stirx frm as the key when sorting. Here are some caveats though. Yeah, me either, dude. Tim, this chapter is like terrible. The author is honestly like, I'm not that impressed. I mean, like, definitely seems like a smart guy, but it's not doing a great job about like explaining things. It's just like throwing these methods at you and being like, here's this, here's this, here's this. It's like, okay, I don't want like method flashcards. I want to like ease me into this stuff. Like, I don't know. I'm honestly tempted to skip this chapter. It's just about stirs. I mean, we're almost there. We're like 10 pages away. But like, if I ever need to come back, I'll read this chapter. But like this, I don't know. This isn't really telling me a lot about like, I mean, yeah, it is, I guess, about Python. But not really prevalent to what I wanted to learn about. It's like boring the hell out of me, man. Like I've been really struggling to keep moving through this book because of this chapter, dude. Even when I work with data pipelines, I don't know what this is. You guys vote we move on to chapter 5. Data class builders. This might be way better. Getting into data classes. Right? I don't know that. Man, why is the reading is so hard? Like I wish it was more enjoyable. I really enjoyed Python Crash Course. I really think it maybe just the book or the author. I don't know. I don't know. I agree. Move to chapter 5. What field do you want to get into after you learn Python? I'm reading Machine Learning with Python Codebook by Chris Albon right now. It's a useful read for real. You want to drop a link in Discord? I can throw it in Discord in community resources. Okay, let's just kind of jump to chapter 5 here. Let's read maybe the first couple of pages here, and then we'll kind of move on to the project. I want to get some project work done and get the file functions going. Data classes are like children. They are okay as a starting point. Okay. Data classes are like children. They are okay at a starting point, but to participate as grown-up object, they need to take on some responsibility. Python offers a few ways to build a simple class. That is just a collection of fields with little or no extra functionality. That pattern is known as a data class. Okay, a data class. Data class. A simple class that is just a collection of fields with little or no extra functionality. This pattern is known as a data class. The data classes is one of the packages that supports this pattern. Data classes. This chapter covers 3 different class builders that you may use as a shortcut to write data classes. Collections.named_tuple, the simplest way, available since Python 2.6. Collections.named_tuple, with capital N, capital T, an alternative that requires type hints on the field since Python 3.5, with class syntax added in 3.6, and @dataclasses.dataclass. A class decorator that allows more customization than previous alternatives, adding lots of options and potential complexity since Python 3.7. After covering those class builders, we will discuss why data class is also the name of a code smell, a coding pattern that may be a symptom of poor object-oriented design. A code smell is a coding pattern that may be a simp? We're not talking about Tim. A poor object-oriented design. Okay. Typing.typedict may seem like another data class builder. It uses similar syntax and is described right after typing.named_tuple in the typing module documentation for Python 3.9. However, typedict does not build concrete classes that you can instantiate. It's just syntax to write type hints for functions, parameters, and variables that will accept mapping values as records with keys as field names. We'll see them in chapter 15, whatever. Okay. What's new in this chapter? This chapter is new with the second edition of Fluent Python. The section classic named tuples on page 169 appears in chapter 2 of the first edition, but the rest of this chapter is completely new. We begin with a high-level overview of the 3 class builders. Okay. Overview of data class builders. Okay, consider a simple class to represent a geographic coordinate pair, as shown in example 5.1. Class/coordinates.py. Class coordinate. We have initialization of a latitude and longitude variable with self.lat and self.long. Easy. The coordinate class does the job of holding latitude and longitude attributes. Writing the init boilerplate becomes old real fast, especially if your class has more than a couple of attributes, each of them mentioned 3 times, and that boilerplate doesn't buy us basic features we'd expect from a Python object. From coordinates, import coordinate. Moscow equals coordinate 5576, 3762. Moscow coordinates object. Location coordinates 50, right, equals false, right? It doesn't support direct comparison between objects because we have to write them in there, right? So in line 1, in line 1 we would use like a repr inherited from object is not very useful, right? This is what was inherited from object because we didn't write one. Meaningless, double equal. The EQ method inherited from object compares object IDs. Comparing 2 coordinates requires explicit comparison of each attribute. Right, the data class builders covered in this chapter provide the necessary init, repr, and equal methods automatically, as well as other useful features. None of the class builders discussed here on inheritance. None of the class builders discussed here depend on inheritance to do their work. Both collections.nameTuple and typing.nameTuple build classes that are tuple subclasses. Data class is a class decorator that does not affect the class hierarchy in any way. Each of them uses different metaprogramming techniques to inject methods and data attributes into class under construction. Here is a coordinate class built with named tuple. Okay, so let's do number 1. Right, we have, this is just collections dot named tuple. Right? A factory function that builds a subclass of tuple with the name and fields you specify. Right? A factory function that builds a subclass of tuple with the name and fields you specify. From coordinates, import name tuple. Coordinates, name tuple, coordinate lat long. Is subclass, coordinate, and tuple true? Okay, so you gave the class name and you gave it a tuple that it represents, rather than having to... Okay, so this is just a way to quickly build these boilerplate constructions on the fly and give them kind of a pre-built repr and equal sign evaluation access to those operators by some just preset code, basically, some preset packaging. Okay, that seems pretty useful. Right, so I guess what you would do is for name tuple, you give a coordinate and then you give a string, a space string, a value space string, I'm guessing, for all the values, object value, variable names of each value in the tuple. So is subclass coordinate tuple is true, coordinate Moscow, and then Moscow equals that coordinate true. Useful repr, meaningful EQ into... The newer typing.nameTuple provides the same functionality, adding a type annotation to each field. Import typing coordinate equals typing.nameTuple. Hey Joe, how's it going, dude? Let me know more about your learning, what you've been learning in Python. You guys are here, I appreciate it. If you guys could leave a like on the stream if you stop in. Thank you guys so much for being here. If you guys are on Twitch, leave a follow. And sorry, I hate asking for all that kind of stuff, but it really does help the stream to keep growing. You know, I'm trying to hit 5K subs by end of year is my goal. End of year is my goal. 5K subs. That's great. All right. Where are we at right now? Are we at 2.5? I think so. Almost to 3. Yeah, 2.5. Okay, so it's really easy. Sort of a beginner stage, watch CS50P, and I've been trying to come up with some beginner projects. Nice, dude. Have you taken a stab at trying Python Crash Course, the book? It's in my Discord link down below if you would want a copy, or you can just find it online too. I'm not gonna keep it a free thing online. But yeah, that's what really helped me to kind of put together what I learned in CS50P and then start building some projects. The newer typing.name tuple. Oop. 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 Come on. Typing.name tuple. Right, provides the same functionality, adding a type annotation to each field. Provides the same function as collections dot collections.name tuple. Also adding a type annotation to each field. So import typing, coordinate.typing.name coordinate. Coordinate is a list with latitude float, longitude float. Get typing, typing.get type hints. Okay, so this just gives you have to assign type hints as well. Okay. Nice, Joe. Yeah, check that out. Give it a stab. That's what those videos I've been uploading on my channel. So I have quite a few up to chapter 5 now. We've just got into chapter 5 on reread, not on like a reread, but just going back through and resolving the try it yourself problems. But filming it for you guys as like some solution videos to go back and reference in your own study. So check out those try it yourself practice problems that I've been posting and see if you can maybe solve the first couple on your own. And then if you are needing some more help, maybe just start reading the book and go through the chapters. Okay. A name tuple can also be constructed with the fields given as keyword arguments like this. Coordinate equals typing.name tuple coordinate, latitude, longitude, float. This is more read one, also lets you provide a mapping. Okay, so you can also do it like kind of like a class would rather than a list also. Since Python 3.6, typing.name tuple can be used as a class statement with type annotations written as described in PEP 526, syntax for variable annotations. This is much more readable and makes it easy to override methods or add new ones. Example 5-2 is the same coordinates class with a pair of float attributes and a custom stir to display coordinate formatted like 55.8 and 37.6 northeast. Okay, so typing import name tuple, class coordinate name tuple, longitude. Oh, can also be used in a class statement with type annotations. So you can write it as a class of a name tuple, inherit from it, and get all of its properties basically. And then you can set and override new one methods or add new ones. And that's cool too. So let's go. Can be used inside class statements. And inherit from named tuple to gain access to the named all right. Nice. These notes are on my GitHub. You guys can access them if you would like. I'll go ahead and push up what I got so far. Move past, I'll say, I didn't finish chapter 4, so move to chapter 5, whatever, it's fine. Yeah, you guys can access these notes and get access and read them over yourselves in my GitHub. Although name tuple appears in the class statement as a superclass, it's actually not. Typing.name tuple uses the advanced functionality of a meta class, footnote 2, to customize the creation of the user's class. Check this out. Is subclass coordinate typing false? Is subclass coordinate tuple true? So meta classes are one of the subjects covered in chapter 24. So it doesn't inherit actually. Doesn't inherit from name tuple, but inherits from tuple type using the typing dot named tuple meta class. The $init method generated by typing.name tuple the fields in the init method. The fields appear as parameters in the same order they appear in the class statement. Like typing.name tuple, the data class decorator supports PEP 526 syntax to declare instance attributes. The decorator reads the variable annotation and automatically generates methods for your class. For comparison, check out the equivalent coordinate class written with the help of a data class decorator as shown in example. Oh, this is the data class decorator. So this is number 3. This is at data class decorator. Right. The decorator reads the variable. The decorator reads the variable annotations and automatically generates methods for your class. The decorator reads the variable annotations and automatically generates methods for your class. Oh. For comparison, check out the equivalent. It makes methods for you? What? That's cool. So example 3.5, data classes coordinates.py. Data classes import data class. At data class frozen equals true. Class coordinate lat is a float, longitude is a float. We have a stir where we say north south is north if south, longitude else west, or south west east is south longitude greater than 0 else west. Note that the body of the class in example 5.2 and 5.3 are identical. The difference is the class statement itself. The at data class decorator does not depend on inheritance or metaclass, so it should not interfere with your own use of these mechanisms. The coordinate class in example 5.3 is a subclass of object. Right, because we're not using the metaclass stuff from the previous example, name tuple. Main features. The different data class builders have a lot in common as summarized in table 5.1. Selected features compared across the 3 data class builders. X stands for an instance of a data class of that kind. So mutable instances, name tuple, data classes are mutable. The newer name tuple and data classes are class statement syntax, right? They all have as dict. The first 2 have fields. The first one you have to parse out from a variable. Get field types. So we'll paste this here. And then we'll say like this. Does not depend on inheritance or meta class data or a meta class, right? So then take this as well. The classes built by typing.name tuple and data class have an annotations attribute holding the type hints for the fields. However, reading from annotations directly is not recommended. Instead, the recommended best practice is to get the information is to call the inspect.getAnnotations my class added in Python 3.10 or typing.getTypeHints my class Python 3.5 to 3.9. That's because those functions provide extra services like resolving forward references and type hints. We'll come back to this issue much later in the book in Problem with Annotations runtime. Yeah, runtime and page 538. Now let's discuss those main features. Mutable instances. So this is main features, right? The different data class builders have a lot in common. We already went over that. Mutable instances. A key difference between these class builders is that the collections.nameTuple and typing.nameTuple build tuple classes, therefore the instances are mutable by default. @data classes provide mutable classes, but the decorator accepts a key keyword argument frozen, shown in example 5.3. When frozen equals true, the class will raise an except when you try to assign a value to a field after the instance is initiated. Class statement. Only nameTuple, typing nameTuple, and data class support regular class statement syntax, making it easier to add methods and doc strings to the class. Construct dict. Both nameTuple variants provide an instance method as dict to construct dict objects from the field data class. The data classes module provides a function to do it at dataclasses.asDict. Get field names and default values. All three class builders let you get the field names and default values that may be configured for them. In nameTuple classes, the metadata is in the _fields and _fields defaults class attributes. You can get the same metadata from a data class decorator using the fields function from the data classes module. Right, this kind of goes over what this chart was. Okay, classic nametuples. Okay, we'll stop here. Okay. Good little read sesh. Good read sesh. 45 minutes of reading. Nice. Okay, let's go ahead and work on Stalker for a second. Time is it? I'm probably going to cut it short today. Been working hard at work, you guys. I'm not trying to burn out. Come on. Stupid cord. Okay. Alright, so last time we left off, we were working on these methods here. Save portfolio and load portfolio. And we need to fix this load portfolio method, right? Currently it's not working because the load portfolio cannot load or unpackage like dictionaries and lists that are assigned to variable values within the dictionaries, right? So that's that. So let's go ahead and see how we can deal with this, right? What's going on, you guys? How you guys doing? Okay. So let's get rid of this first. Okay. So I think the easiest way to do this is in the constructor, right, for the accounts. Rather than assigning accounts to here if the accounts is not none, right? What we'll do is we'll assign accounts right, so in my portfolio here, my accounts is a list. Right, so we're gonna have to say so let's rewrite this. Let's say this is going to equal right? This is going to equal a dictionary where we'll say key how should I say that? So let's first just do this. Let's say if accounts is none, right? We're going to assign to defaults right? So the default is to account if it is none. If it's not none, what are we going to do? Right? Well, we know that the accounts so else we want to create a dictionary where we have else we're going to say for account, for accounts, we're going to create an account for the said account. Say so we'll say we'll create an account object for the account, right? So the account is going to be received as this here, a list. And so we're going to say for account, which is an object, we're going to call right account.name. Okay, so let's do this. Boom. Return account.name account for account in accounts. But this is not going to be account.name, this is account quote name, right? Right? If account if accounts is not. So then we don't even need this. Say self that. Like such. I think, right? So if I call create an account for every account in here. And then in the construction of the account, we need to create a portfolio. We need to create something similar here. We need to say position dot name So what is my position? It's a list with just each with the position. Position, quote ticker. I just want to create a position. How am I storing these objects? We're storing what attributes? I'm confused. Okay, so this takes, we're going to create a position ticker. Which it takes strings. Position ticker for position in position for positions in position. I'm confused. Is this one okay? I want to create an account name. Account. Hold on one second. Hello?
Hello?
Hey, what's up? I'm streaming right now.
Oh, okay.
You okay?
Yeah. This is the only time I've been alone.
Oh, sorry about that.
Talking. It's okay. I'll talk to you later.
Alright, bye. Okay. Okay, so we want to set the account name as the key and the value as the account for account in accounts given in the constructor if the account something like this. So the thing is why does this what's here? I say position name or ticker for position for position in positions if positions are not. I think this one. Nice, Abdul. Congrats, my guy. I think it's positions and accounts. Right, if it's accounts. So if I run testing pi here, non-object, non-iterable for accounts. Well, if it is none, right? Well, I should have accounts coming in here. Okay, so it's trying to. Okay, so even it's trying to still do. So we'll say if accounts is none, we're gonna say right. Else we'll set this account. It's not none in position. institution. Okay, so you have to give right. Set the institution here. If it's none, okay, count. Okay, almost. We're getting, okay, so cash is getting successfully given back, but not these two values. Right. I had a conversation with Chat about this a couple days ago. So we got the account objects. I'm going to quickly define an account. Duster. Oh my gosh. For account in let me call right, so this is what it looks like now. Hmm. Hey Ray, how's it going? Hmm. So I'm trying to deal with this part here, right? So if given an account, right, we're gonna load in this. So in our portfolio, in load, we just call json.loads. Let me come here and print file content here. So we've got the file content here, right? So what I do, okay, what I'll do, go back. I'm not gonna create accounts on instantiation in here. I don't want it to happen out here within my constructor. I want it to happen in my function of loading. Okay, we're here, we're back, okay? Let me go to here. Okay. Okay, so what we'll do is in load profile, I'm gonna say, I'm gonna create a, for, so if I create a portfolio given the file content and I unpackage this, what happens here? Okay. predict, which propagates down to all the other things. Okay, so that won't work. So let's go ahead and print. Get rid of this. Yeah. Yeah, it's about stocks. Print temp. Let's print temp. Give me a portfolio object. Right. Where it's accounts. Now let me print temp accounts. Okay. So a list of dictionaries. Perfect. Okay. I dumped to dict which propagates in. Okay, so then let's save this. We just need to go like this. Right, we need to go like this. We need to go like this. We need to go. Okay, so we got access to all the template create portfolio given the content here. Right? Now if I go ahead and I print, so we just need to go like this, right? So let's say we have a list of accounts, right? So we should say we want to create the account. For account in loaded portfolio.accounts, we want to set account. We want to first create an account given the account here. And we want to unpack its variables. Loaded account equals to this, right? Account, loaded account. We're going to say loaded account dot parent portfolio we want to set the parent portfolio to the loaded portfolio for every account. Right, so that overrides that string of dummy investments to back to the parent. Right? And then we say for position in count dot positions, right, loaded position is equal to loaded position is a position given the position we're currently working with. We'll unpack that into the loaded position, creating there, and then we'll say loaded position dot parent dot parent account is equal to loaded account dot positions, loaded account, right? So that'll set the value of the position, all the positions within set account, to the account. So now what we're going to do is, after we run this entire loop over all the accounts, we're going to return the loaded portfolio. And then in testing.py, we'll get loaded portfolio from this, and then we can print loaded portfolio dot to dict here. Okay, good. This object has no attribute values. This is for accounts here, which is a dictionary of all the accounts and portfolio, hiding account, creating account, name, account. Okay, so I need to set will look like this. Format converted accounts is equal to a blank dictionary, right? And we're going to take the account after we go through all the accounts. After we get done with the account, so after we get done with the account here, we're going to go into its positions and get done with its positions. And once we're done with the positions in the account, what we're going to do is we're going to say converted accounts index key of loaded account dot name is equal to loaded account. And then for all the positions, once we get done creating a position, so we're going to have to create a converted positions is equal to a dictionary here, right? We're going to go into, once we set the parent account, we're going to go into converted positions key of loaded position dot ticker, and we're going to set that equal to the value of the loaded position. And then at the end of this entire loop, we're going to set loaded, or at the end of this entire loop over the positions, we're going to add the account to the converted accounts. But first, we're going to add the position for this account. So loaded account index of loaded account dot positions is equal to the converted positions list here. And then we set the accounts to here. Sorry, here. We set the, now we have the finalized account into here. Then at the end of the loop, we call return, or what we'll do is we'll say loaded account dot accounts loaded portfolio, my bad, is equal to the converted accounts. And then we return the loaded portfolio. So now if I call this, boom, no error. Okay, let's see here. Let me go ahead and go into portfolio and remove that print statement that we had. Okay, so now if I print just this, I get portfolio created, Deming investments, cash, stock asset value. There's a 1. Realized gain is 1. Well, unrealized gain is 1. Huh. Huh. Hmm. So I go to portfolio here. In my print, or in my load here. So what I want to do is create a portfolio. So what I'm going to do is I'm going to go like this. Name equals file content index name. Um, accounts equals to file content counts. Cash, stock asset value, unrealized gain. Unrealized gain. Set these deliberately. Huh. I guess that value should be this. No. Um, hmm. So we're going into here. I'm going to print file content. So let me print content here. Stock asset value 420. Counts. Shares is 1 inside of there. Huh. This is interesting. I want to see. Let me print file content stock asset value. For 20.02. So why would this be then overridden to 1? Not using a 1 anywhere in this file. Doesn't make any sense. But yet, my stock asset value is being set to 1, and same with unrealized gain. Huh. I'm curious. Let me take this guy. Let me see here. I am loading in my JSON file or my port, which contains a list of accounts, which each contain a list of positions. I converted all sub accounts and positions into dict and am not and am however, when I print the file content stock asset value, I get the 420 whatever. But printing Combinations with file content. Portfolio unit construction. Alright, init logic for oh, why do I have that? What? Why did I have that? Why is that way? Unrealized gain of unrealized gain. Why did I have that wrong? I remember doing that. Okay. Now if I run Loading raw dicts from JSON, reconstructing portfolio position instances, reading, linking parent-child inferences. Key. I'll name variables I put before converted. Yeah, we could move into class methods. Use default data keys as soon as possible. Huh. Okay. I think that did it. I think that did it. Yay! All right, so what we've got here now is the ability to load the portfolio. Right, I'll print it, and then I'm going to call save portfolio, but I'm going to delete this in between and make sure it looks the exact same. So what I'm going to do is I'm going to take a screenshot of this, right? This is what it looks like, okay? I'm going to go here. I'm going to go to testing.py. I'm going to call I'm just going to run this once. Okay, this runs perfect. So now we have saved what's on here. Now if I call this one more time down here, does this change at all? So if I run testing py here, does this update and overwrite? Well, the price just updated, that's why. Now if I run this, it looks the exact same. Now if I delete it, it comes back. Is that the exact same? Come on, show me the money. Oh, it was in my screenshots here. Yeah, let's go. We got it. Okay, sweet. So, in case you're wondering what we just did there, you might be like, well, what did we just do? Like, what was that all about? Like, why did we go through and have to do all this stuff in this method here? Okay, so what I'm doing is I need to, hey, 9-inch Tony, I don't know, you tell me. So what I needed to do was I needed to take all of our objects, right? So currently we have a portfolio, which is a class. And in portfolio, we have accounts, which are classes. And in accounts, we have positions, which are classes. And in order to write objects to JSON, we need to convert all of them to be serializable. So we need to convert them to dictionaries to represent just like a screenshot of the class just in dictionary form. All of the instance variables as keys and all the values of those variables as the values of those keys, right? Cool, like a screenshot of the class to make it whatever it was for JSON, serializable, right? Okay, now, so what I'm doing is I'm calling save portfolio on the given portfolio, right? So my current portfolio dot save portfolio. And what that will do is it will call dict or call self dot to dict, right? And self dot to dict propagates down accounts dot to dict, right? And when you do accounts dot to dict, that propagates down positions dot to dict. So it just continually propagates down dictionary conversions for every account and for every position within the dictionary conversion of the actual portfolio. So we convert the portfolio to a dictionary, that propagates all the accounts to convert to dictionaries, that propagates all the positions to convert to dictionaries. Okay, cool, really simple. And then we just save that file, we save that to this. So, right, we get a dictionary of a portfolio here in the yellow, right? The yellow braces are the portfolio, the outside ones, which are these values here, right? Then we have the accounts, which are going to be these guys here, right? Which are written as dictionaries. Here's dictionary number 1 for account number 1. Here's dictionary number 2 for account number 2, right? And then we go and we have positions within the accounts, which are position number 1. And I don't have any other, and then we just have position number 2, right? Yada, yada, yada. And position number 1 in this account, right? And so then what we're doing is now we need to basically do the reverse, right? We took a screenshot basically of all of the position, all of the accounts, and all of the and the portfolio as a whole. We took a screenshot of what it looked like in all of its values at that exact moment. Now we need to unfold it and reconstruct all the objects by loading it back in. So what I'm doing is I'm saying, okay, load portfolio given a file path. Okay, so we'll load based on some file. We'll open that path as the file. We'll load it as JSON. So we're going to take all of this and we're basically going to get a dictionary with all of this inside. This is exactly as that's going to look like in Python. A dictionary with a key of name and this as a value. A key of cache, this, key of stock, key of accounts with a list of all of the accounts, right? And so but what I'm doing then is that's on file content. I then am creating a portfolio given the loaded portfolio, right? So I want to see something. Will this still work if I just do that kind of Python shorthand here and just do * file content and run testing py here? Yes. So cool. Okay, so we can just do that rather. So what this does in Python is this * unpacks all of the key value operator pairs within account and basically builds the account for us or matches those pairings to the account parameters, right? Cool. And so then we have a loaded account, right? We've loaded basically, we've created we have a loaded portfolio, which houses all the portfolio contents. Now we need to go through all of the accounts, right? Because currently they're in this kind of list form, right? A list of accounts all jumbled together, right? We need to go in their dictionaries, right? They're not actually objects anymore. So we need to go back through and convert them to their objects again, right? In one of my first projects, my very first project, the inventory management system, chemical inventory manager, I made the mistake of doing a similar type of saving, but then I didn't convert the objects back into objects from the file. So what I was doing was I would have half of my program when I was working with live data from the file was using, key value object notation, accessing objects key values because the objects now were in dictionary format loaded from the file, whereas then stuff that was loaded initially from the instantiation was being accessed via dot notation. So I had parts of my my code base that were being objects that were being accessed post file were being notated and accessed in a different way, and objects that were being created live during the process were being notated with dot notation. So I was really confused going back and forth. So now what we're going to do is we're just going to bite the bullet and just convert all the data points into their appropriate objects so that we can access all of the methods and whatnot within the class. We don't need to make auxiliary methods, that it can be kind of nested all within their own constructed classes, which is really cool and kind of organized. So, but I'm So, right, we're converting the objects or the information back into their objects. We're taking the account dictionaries from the static file and converting them back into account class objects, right? But I was getting an error early if you saw that because um, I have my accounts are being they're not it's not a list of just the accounts, right? They're kind of formatted in a way that I can strategically get access to the information faster than just a raw list of accounts where I have to iterate one by one through each account to get access to it. I didn't want to do that just by having just a list of accounts, right? So instead I have a dictionary of accounts where I have the key as the account's name and I have the value as the actual account object, so I can get O of 1 constant time or quick access to that specific account by referencing it by name, right? So I don't have to go and iterate through a list of accounts searching for a name attribute within the account, right? And then once I find that, break and then return, which is in the O of n worst case, I just instead am going to create a dictionary of accounts. And then so what I had to do is kind of convert rather than just appending, right? When I load in and go through the accounts and parse through them, rather than just appending the account to the loaded portfolio's accounts, list. How it's not a list, remember? So loaded portfolio dot accounts is a dictionary, and I set it equal to converted accounts, which is this dictionary here, which we are setting converted accounts to be the loaded account name and the loaded account after we convert all of its positions as well in a similar format. Now, yes, it's there's a lot going on. I'm kind of following it just because I've been writing the code on this project from the start. So if you're jumping in here, it might be a little bit confusing, but just know that we are creating accounts. We're creating a portfolio. We're going through the portfolio into its individual accounts. We're taking the static accounts from the file and reconstructing them back into their objects, assigning the parent relationship back to the linkage from the account to the portfolio, and then going through the positions in the account and also converting those. And then rather than just appending to a list, we're using a different type of data structure as a kind of a mapping to accounts and portfolio and positions, so we can get constant access by accessing the name of the account or the ticker symbol of the position within the account. So it's kind of neat. It's a little bit better optimized that way. And then what we do is we just take our loaded portfolio and now override the accounts with the converted accounts dictionary, right? Because currently it's just a list of static accounts, just like this, right? It's not we didn't actually we accessed all of this information and did stuff with it. We created accounts, but we never actually did anything with this actually accounts variable. It still equals all of this. So we have to go ahead and um, actually set the loaded portfolio accounts to the converted accounts, as well as we had to do the loaded account. We had to do where was it? This is loaded portfolio right here. Loaded account dot positions, right? Right. You have to overwrite the account dot positions var currently um, from the file um, as the converted dict object structure. And then you have to do the same thing here, right? Overwrite the portfolio dot accounts dict object structure with the converted accounts. Just saw you on my recommended list. I have a non-tech job background. I wanted to transition to tech. Your dedication and motivation to show up inspires me to push forward and study harder. Hey, dude. Hey, thanks, Better Potato. I appreciate you. Why not just store accounts as key value objects in JSON as well? Why not store accounts in key? Oh, you're saying like just have accounts be key values as like account one, and then boom, account two, account three, account four. I can see what you're saying, right? We could just have it be within the portfolio scope of accounts here. I get what you're saying. So this would be account one, and then it would house account one. I mean, yeah, it's interesting, right? It's kind of, I definitely that's definitely a way to do it too. Because right now I have my object, and then one value of the object has a list, and then I have my object, and one value of the object has a list. So it kind of keeps a very like not linear, but like consistent structure throughout the entire frame of each scope, from portfolio to account to like accounts with a dictionary. Well, the thing is, my account, the thing is I'm saving the name as the key, and then the value as the actual account, right? Which is that's what's going on, right? Inside of the class, right? Because that's how I'm constructing it here for an account as, right, accounts is a dictionary with the key of a stir and the value as an account, right? So I could structure it just a dictionary of accounts. But I kind of want to be able to distinguish account from account by a separate dictionary key, right? Because if you have just a single dictionary, there's nothing that would distinguish account from account within a single dictionary, right? Unless you have another dictionary of accounts, right? But then it just becomes, I mean, we're still doing the same thing. We would just have a dictionary of dictionaries versus a list of dictionaries. But I guess it makes, yeah, because we are having a dictionary of dictionaries here. No, because, sorry, we're just having a dictionary. Yeah, it's interesting. Well, they could build for a large n, so we're keeping those things in mind at now, right? Right? They could have a very large n number of positions or accounts or whatever. Like it really doesn't matter, and so it's just good practice to keep those things in mind, especially when dealing with data that the user could be entering here, and especially have a huge file of all these accounts and stuff. This is just one position over two accounts, right? So it's just good things to keep in mind for optimizing. Cool. All right, so we were successful today. It feels good. Feels good. So what we did is we got our load function to actually work here. So now we can load in our portfolio. We can create a portfolio, right? Save it and then reconstruct it exactly one to one as it was before, and then save it back again. So we're creating all these objects, right? And then we're saving them, And then as you can see, we're bringing them back here. And then we're just printing out the actual portfolio here after we've created it again on the load. How's it going, Anon? Welcome back in, my guy. All right, you guys. Cool. So for those wondering, we're building Stalker, which is a stock kind of dashboard, basically an entire net worth portfolio view where you can have accounts linked from various different institutions such as like Robinhood or Fidelity or Schwab or wherever. You can link those accounts, not actually physically like with logging in or whatever. I don't have that crazy, but just by manually entering in the information pertinent or pertaining to that account, and then you can get an entire portfolio view across all your accounts. So currently we've been working on the accounts page here, which looks really nice. I have no styling done. There's no styling done. This is all just raw widgets. So I will be going back through kind of towards the end and styling it, but once I get the functionality going. But so you'll have the ability to select an account, all of them or an individual one, and then view, which will populate the header here with all the information for that account. And then you can update the cash value of the account or refresh to get the refresh stock price, and then refresh all the stock prices for your positions. And then obviously it'll list out your positions here in the matrix, and then you can go ahead and filter through your positions via the header here, which will be cool as well. So, and then you have a transaction. So as you do various things such as update cash or add an account or whatever, we have a transaction class that will be placed at strategic points throughout the script that will just basically log and create entries for those various transactions or kind of events that take place, such as adding an account, updating cash. It'll be like, okay, cash updated on blah, blah, blah on this date, yada, yada. So I just have a dummy thing in here one-to-one with this guy so I could get it structured. But then you could obviously filter through your transactions and see what you did and when as well. And then settings to kind of fine-tune things. But yeah, it looks pretty good so far. I'm pretty happy with it. And then obviously once we get the account working appropriately in positions, then we can kind of fill in the information pretty easily with the portfolio section, and it should be pretty good. So thank you guys so much for being here and joining me. Sorry, it was a little bit shorter one today, just only 2 hours. We usually do about 2.5 or 3. But I've been working hard at work. For those that don't know, my name is Michael. I'm 26. I have a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company, 9 to 5 every day for full time. So I've been teaching myself how to code for about a year now after my job. Every single day I've been grinding code, learning code, reading books. We read Fluent Python at the beginning of the stream. We read about 10 or 15 pages today, which is really nice. And then we wrote and kind of fine-tuned our load and save functions for the portfolio, which was a big task. So let's get add here. Let's commit this bad boy. You can get access to the code on GitHub. So fix load / save portfolio functions. And then if you guys want to participate, feel free. You guys can join my Discord link down below to kind of chat with everybody about features and stuff that we want to add. Nobody really wants to participate in it though. I think people might be kind of lost or don't know where to put theirs. Give anything. I don't really care. Anyways, you guys, thanks so much for being here and hanging out with me today. Please subscribe if you're new. I stream every single day around 7 p.m. PST after my 9 to 5 job as a chemist. Sorry there was no music this stream. I forgot my headphones at work, so I couldn't really play any tunes or else we get a really bad echo through the mic. So I'm sorry, that's my bad. I could have worn my headphones things here, but I look like a pilot, so I don't want to do that. But so anyways, you guys, sorry I'm rambling. I'll see you guys tomorrow. Thanks so much for being here. Yeah, see you guys tomorrow. Bye.